Hi there, and welcome to this lesson on Further Pure Mathematics 3. And in this lesson, we're on Chapter 1, 1.1, and an introduction to hyperbolic functions. What are hyperbolic functions? Well, there is a very close connection between the hyperbolic functions and the standard trigonometric functions. And for that reason, the same notation is used for them, except we add the letter H for hyperbolic. So, for example, we have these three functions, and the most common way of pronouncing them is sin x, cos x, and tan x. Both the hyperbolic functions and the trigonometric functions can be defined in terms of the exponential function e to the x. So sin x is equal to e to the ix minus e to the minus ix divided by 2I, and cos x is equal to e to the ix plus e to the minus ix divided by 2. The hyperbolic functions have got exactly the same form, but without the complex element. So the hyperbolic function sin x is defined to be e to the x minus e to the minus x divided by 2, and the hyperbolic function cos x is defined to be e to the x plus e to the minus x divided by 2, both of which are actually a great deal simpler than the definitions of sine and cos. Just as tan x is equal to sin x divided by cos x, the hyperbolic function tan x is defined to be sin x divided by cos x, which would give us tan x equals that, which simplifies to this. Now, you may sometimes see this written down as the definition of tan x, but more frequently this is simplified by multiplying the numerator and the denominator by e to the x. And that gives us this, multiplying through by the e to the x, then tan x simplifies to e to the 2x minus 1 divided by e to the 2x plus 1. And it's this definition of tan x that we'll be using in this lesson. The reciprocal hyperbolic functions are defined in the same way as the reciprocal trigonometric functions. So cosec x, which is how that's pronounced, is 1 divided by sin x, which is this. Sec x is 1 over cos x, which is this. And cos x is 1 over tan x, which is this. Okay, let's have a look at an example. Example 1, evaluate the following to 3 decimal places. Now, all we have to do is use the definition of the relevant function and substitute in x equals whatever we're given. So for sin x, we'll be substituting in x is equal to 5. I'll let you have a go at working your way through these. You just use your calculator and then round the answer to 3 decimal places. So pause the video, have a go, and come back to me when you're ready. Okay, let's have a look. So sin 5, first of all, that's the formula for sin x. We substitute in x equals 5, which gives us that. You just put all of that in the calculator, which gives us 74.203. Part 2, tan of 0.5, that's the formula for tan x. If we substitute in x equals 0.5, then we will get that. And again, put that in the calculator and you get 0.462. And sec minus 2, I'll use the formula for sec x, which is that, and substitute in x equals minus 2. Put that in the calculator and we get 0.266 for the answer. Example 2, without using a calculator, find the exact value of tan log 3. We'll be using the formula for tan x, we'll be substituting in x equals log 3, and then we need to do a little bit of manipulation of what we have in order to find the exact value. I'll let you have a go at working out exactly what we do. So pause the video, see if you can work your way through this, and then come back to me when you're ready. Okay, let's have a look. So that's the formula for tan x. Substituting in x equals log 3 is this. Now, there's an important process which we use quite a lot with exponentials and natural logarithms, and it's dealing with this 2 here. And we change the 2 into a power using one of the rules for powers, and that gives us e to the log 3 squared on the top, minus 1, and e to the log 3 squared plus 1 on the bottom of the fraction. And the reason for doing that is it brings the e and the natural logarithm together, And because they're inverse functions to each other, they essentially cancel each other out. And that gives us 3 squared minus 1 on the top and 3 squared plus 1 on the bottom, which simplifies to that, which simplifies to 4/5. Example 3, use the definition of cosh x to find x if cosh x is equal to 3. And we're asked to find that to 2 decimal places. So this time we know the answer, so we'll be saying e to the x plus e to the minus x over 2 is equal to 3. And what we want to do is create a quadratic equation in e to the x, which we'll then solve in order to find x. I'll let you have a go at working your way through that yourself. So pause the video, see if you can make sense of this, and come back to me when you're ready. Okay, let's have a look. So that's the formula for cosh x, e to the x plus e to the minus x over 2, and we're told that that's equal to 3. Moving the 2 to the other side would give us that. And then if I multiply every term by e to the x, it's a common process where we have something like this, where the power is plus 1x here and the power is minus 1x there. That will give us e to the 2x plus 1 is equal to 6e to the x. And moving the 6e to the x over to the other side gives us that. And then the important thing is to notice that e to the 2x is equal to e to the x squared. So what we have here is a quadratic equation in e to the x. We can solve that using the quadratic formula, and that will give us 2 solutions. E to the x is equal to 3 plus or minus 2 root 2. 3 take away 2 root 2 is a negative number because 2 root 2 is greater than 3. But e to the x cannot be negative, e to the x is always positive. Therefore, there is only one solution, which is e to the x equals 3 plus 2 root 2. If I take the logarithm of both sides, that will give me x equals log of 3 plus 2 root 2. And if the question had asked me to find the exact answer, that is where I'd stop. So that is the exact solution, x equals log 3 plus 2 root 2. But the question asked me to find the answer correct to 2 decimal places. So I'll pop that in the calculator, which gives me x equals 1.76 to 2 decimal places. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 3 and have a go at exercise 1A. Thank you very much for listening, and cheerio.